Welcome, curious minds and avid stargazers, to a journey into the vast unknown, a tale of mystery and marvel that transcends our understanding of space exploration. In today's documentary, we are going to reveal the shocking secret behind Voyager's latest transmission along with Voyager history and discoveries over time, an enigma that is stirring excitement and speculation in scientific communities around the globe. Stay with us as we take you through an in-depth narrative that not only examines the technical details behind this groundbreaking discovery, but also sets it against the rich historical backdrop of the Voyager mission. In the next several minutes, prepare to embark on a suspense-filled odyssey that will answer many questions while sparking new ones. We will begin by teasing you with details hinting at the unprecedented nature of the transmission, walk you through the storied history of Voyager's journey, delve into the technical intricacies behind the mysterious signal, and then explore the wide-ranging implications of deciphering this cosmic message. For anyone with a fascination for space science, interstellar exploration, or the unknown enigmas of our universe, this documentary is tailored just for you. Imagine receiving a message from a distant relic, a probe that has left our solar system decades ago and is now drifting in the interstellar void. In an era where we have come to rely on digital communications and instant data transfer, there arises a transmission that defies conventional expectations. Voyager, our enduring emissary from the 1970s, has sent back a signal so perplexing that experts are hard-pressed to ascribe it to any known natural phenomenon or engineered protocol. What could possibly be hidden within this sequence of data beamed across unimaginable distances? Early observations of the signal reveal an intricate pattern layered into its waveform, a series of rhythmic pulses interspersed with unexpected modulations. At first glance, these modulations might be dismissed as mere interference or artifacts of aging instruments. However, as researchers employed sophisticated analysis techniques, a persistent structure within the noise emerged, suggesting that Voyager itself may have stumbled onto something far more complex than the background chatter of interstellar space. In the coming segments, we'll reveal how this transmission not only challenges our understanding of deep space communications, but may also beckon us to reconsider the limits of technology and the cosmic relationships that bind our universe. We invite you to ponder alongside us as we present each detail, every minute clue, and the systematic investigations undertaken by a dedicated cohort of astronomers, engineers, and theoreticians. In an era defined by scientific optimism and a hunger for discovery, NASA embarked on an ambitious project that would lead to the creation of two spacecraft, Voyager 1 and Voyager 2. These daring emissaries of Earth were designed not merely as mechanical wanderers, but as symbolic ambassadors of human ingenuity, bearing with them the golden record, a message in a bottle, intended for any intelligent life that might one day come across them. At their core, the Voyagers were tasked with exploring the outer planets, gathering data, snapping unprecedented images, and, most importantly, redefining what was possible in the realm of space exploration. This documentary takes you on a journey from the mission's inception through the decades of discoveries that have continuously reshaped our understanding of the celestial bodies in our solar neighborhood, and into an era where Voyager's legacy endures as a beacon of human wonder and perseverance. Join us as we travel back in time and follow the intricate timeline of Voyager's transformative discoveries. A journey filled with thrilling scientific revelations, surprising encounters, and a narrative that continues to evoke wonder and curiosity. Whether you are a seasoned astronomer or someone with a casual interest in space, the story of Voyager is one that promises to ignite your passion for the unknown. The late 1960s and early 1970s were a period of intense innovation and spirited competition in the field of space exploration. The Apollo missions had demonstrated that mankind could leave the boundaries of Earth and set foot on another celestial body. Yet, there remained vast regions of our solar system still shrouded in mystery. The concept of a grand tour, an ambitious plan to visit multiple planets in a single mission, captivated the minds of those working in the aerospace community. Under this vision, Voyager was born as a means to harness the planetary alignment that occurs only once every 176 years. This alignment offered a rare opportunity for a spacecraft to use gravitational assists from the giant planets to dramatically increase its speed and trajectory while conserving precious fuel and resources. In essence, the Voyagers were crafted to be time-traveling emissaries, carrying humanity's legacy and curiosity deep into the labyrinth of the outer solar system. The technological brilliance of the Voyager missions cannot be understated. Each spacecraft was equipped with a suite of scientific instruments designed to capture a wealth of data. From magnetometers and plasma instruments to cameras capable of revealing unprecedented details about the outer planets and their moons. Beyond the raw engineering, however, was a philosophy of exploration that sought to merge form and function with creativity and purpose. The most iconic of these instruments was undoubtedly the Golden Record, a phonograph record embedded with sounds and images chosen to portray the diversity of life and culture on Earth. This artifact was intended to serve as a greeting to any extraterrestrial intelligence that might encounter the spacecraft, a message from a civilization reaching out across the cosmos. In many ways, the Golden Record epitomizes the spirit of Voyager, a blend of scientific rigor, artistic expression, and an ever-present hope that we are not alone in the universe. As the spacecraft were assembled and tested, waves of excitement and anticipation reverberated through the scientific community. The launch of Voyager 2 on August 20, 1977, followed by Voyager 1 on September 5, 1977, was not simply the initiation of a scientific mission, but the ignition of a journey that would captivate generations. The late 1970s witnessed the first tantalizing glimpses of the outer reaches of our solar system. As Voyager 2 was en route to its initial planetary targets, the groundwork was laid for discoveries that, in their time, seemed as surreal as science fiction. During this period, the Voyagers captured some of the first detailed images of the gas giants and their moons, revealing swirling atmospheres, tumultuous storms, and a host of features that would soon define our image of these distant worlds. The discovery of active volcanism on Jupiter's moon Io, for example, marked a turning point in planetary science. Until then, volcanism had been observed only on Earth, and the active, ever-changing landscape of Io provided an entirely new perspective on geologic activity in the outer solar system. Alongside these discoveries, scientists noted the intricate magnetospheres of the giant planets, a phenomenon that not only underscored the dynamic nature of the planets themselves, but also challenged long-standing theories about planetary magnetic fields. Each transmission sent back from Voyager carried with it a sense of wonder and the promise of countless mysteries yet to be unraveled. The mission's early success set in motion a period of exponential growth in our knowledge of the outer solar system. Though still decades away from its current interstellar status, Voyager's trajectory was already a symbol of humanity's relentless pursuit of the unknown. Entering the 1980s, the data returned by both Voyager spacecraft heralded an era of intense scientific discovery and global fascination. This was the decade when Voyager truly earned its place among the pantheon of great exploratory missions. The grand tour of the outer planets, a once-in-a-lifetime opportunity, unfolded before our eyes, revealing wonders that defied human imagination. Voyager 2's flybys of Neptune and Uranus were particularly revelatory. Neptune's striking blue hue and dynamic weather patterns, accelerated by winds that raced across the planet at astonishing speeds, painted a picture of a world that was both beautiful and alien. One of the most dramatic moments came with the discovery of Neptune's moon Triton, an icy world with geysers that spewed nitrogen gas into space. Triton's retrograde orbit further deepened the mystery of Neptune's satellite system, sparking debates and inspiring new models of planetary formation. Meanwhile, Voyager 1's close encounter with Saturn provided breathtaking imagery of the ringed giant. The intricate structure of Saturn's rings, with their delicate divisions and pronounced gaps, defied the simplistic models of planetary rings that had existed before. As scientists analyzed the scattered data, it became increasingly clear that these rings were dynamic, evolving systems, shaped by the gravitational influence of nearby moons and the subtle interplay of cosmic forces. Throughout the 1980s, the Voyager missions not only deepened our understanding of the physical characteristics of these distant worlds, but also expanded our knowledge of the underlying physics governing planetary systems. From the charged particles trapped in magnetic fields to the complex interactions between atmospheres and their moons, each discovery was a tantalizing glimpse into the complexity of our solar neighborhood. As our technological capabilities evolved in parallel with these discoveries, a clearer picture of the outer planets and the cosmic forces that influence them began to emerge. The 1980s truly were a time when the boundaries between science and art blurred, as inspired images and breakthrough data fueled both scientific inquiry and popular culture. With the dawn of the 1990s came a decade of introspection and expansion, a time when the Voyagers, having completed their grand tour of the planetary system, began to signal the start of a new chapter in exploration, the transition from interplanetary to interstellar travel. Although the spacecraft were originally built to study the planets, their continued journey into the vast expanse of space has provided scientists with a unique vantage point from which to study the interstellar medium. One of the most intriguing developments during this decade was the detection of the boundary where the solar wind, a stream of charged particles emanating from the Sun, began to give way to the interstellar environment. This region, known as the heliopause, marked a dramatic transition in the physical conditions of space, offering insights into how our solar system interacts with the broader galaxy. The 1990s also saw the Voyagers providing unprecedented measurements of cosmic rays and interstellar particles. These discoveries helped refine our models of particle physics and magnetohydrodynamics, offering a glimpse into the energetic environment that shapes not only our solar system, but also countless other star systems in the galaxy. As the Voyagers ventured further away from Earth, each new dataset was a challenge to scientists. How do we interpret this wealth of information from a realm that had previously been only a theoretical frontier? The answers were not always clear-cut. Instead, each discovery prompted new questions, inspired innovative theory, and ultimately fueled a decades-long dialogue between observation and hypothesis. Throughout the 1990s, public interest in the Voyager missions experienced a resurgence. Documentaries, news articles, and science programs began to frequently reference the Voyagers as symbols of human curiosity, resilience, and the unyielding quest for knowledge. The pioneering spirit of these missions reminded us that, even when facing the vast indifference of space, human beings remain determined to push the boundaries of what is known. With the turn of the millennium, the Voyager missions entered a phase that was as much about legacy as it was about discovery. By now, Voyager 1 and Voyager 2 had become more than just spacecraft. They had evolved into time capsules carrying decades of invaluable data and images that continue to inspire awe. In the 2000s, a renewed focus on the outer reaches of our solar system led scientists to re-examine older data, combining it with new observations to yield insights that were previously unattainable. The detailed maps of planetary atmospheres and magnetic environments were instrumental in shaping subsequent missions and informing the design of newer, more advanced spacecraft. A legacy of rigorous study and methodical observation had been etched into every byte of Voyager data, inviting scientists to revisit and reinterpret decades-old measurements in light of contemporary advances. This decade also witnessed the dawning realization that the Voyagers were now venturing into interstellar space, a realm that had once existed only in the imagination of science fiction writers. In 2004 and 2007, as Voyager 1 and Voyager 2 approached the edges of the heliosphere, they began transmitting data that offered a glimpse into the properties of the interstellar medium. Researchers observed a subtle intermingling of solar and galactic influences, a phenomenon that provided crucial clues about the structure of our cosmic neighborhood. Meanwhile, the technological resilience of the Voyager spacecraft was on full display. Despite being launched more than 3 decades earlier, their instruments continued to operate, albeit with diminished power, pushing the boundaries of what aging technology could achieve. This remarkable longevity not only underscored the ingenuity of their design, but also served as a rallying point for enthusiasts of space exploration around the globe. The early 2000s united people across generations in a shared sense of wonder, as laypeople and experts alike marveled at the continuing journey of these spacecraft. The narrative of Voyager evolved into a symbol of endurance, a testament to the fact that exploration is an infinite pursuit. Every new measurement, every unexpected twist in the data reaffirmed that space, the final frontier, holds mysteries that defy easy explanation and demand continued investigation. Entering the 2010s, the Voyager missions found themselves at a unique juncture in the annals of space exploration. With the boundaries of the solar system now thoroughly charted, the focus shifted from planetary study to understanding the broader context in which our solar system exists. The Voyagers were now ambassadors not just of human technological achievement, but of the ever-unfolding saga of cosmic evolution. In this decade, scientists honed in on the interactions between the solar wind and the interstellar medium, striving to characterize the properties of the turbulence and magnetic phenomena that permeate the galaxy. Voyager 1's crossing of the heliopause in 2012 was heralded as one of the most significant milestones in modern space exploration. As it journeyed into the unknown, it carried with it the collective curiosity of a species determined to understand its place in the cosmos. The data streaming back from the Voyagers during the 2010s not only refined our models of the interstellar environment, but also provided an unexpected bonus: insights into the evolution of cosmic rays and the energetic particles that permeate the vast emptiness of space. These findings have profound implications for our understanding of astrophysical phenomena ranging from supernova remnants to the very dynamics of the Milky Way. Culturally, the Voyager missions experienced a renaissance during this period. The spacecraft became icons of perseverance and exploration. Museums, planetariums, and educational institutions around the world held special exhibitions to honor their journey. Documentaries and feature films revisited the saga of the Voyager missions, each narrative threading together themes of innovation, resilience, and the boundless hunger for knowledge. For contemporary audiences, the story of Voyager 1 and Voyager 2 in the 2010s was more than just a chronicle of scientific achievement. It was a reflection of the human spirit itself. In a world often characterized by rapid change and fleeting trends, the Voyagers stood as steadfast reminders of what can be accomplished when humanity ventures boldly into the unknown. As we move into the 2020s, the Voyager missions continue to captivate and inspire. Although their power sources wane and communication delays lengthen with the increasing distance from Earth, the legacy of these spacecraft is as potent as ever. Today, Voyager 1 and Voyager 2 are not only scientific instruments but cherished relics of an extraordinary epoch in human exploration. Researchers are hard at work analyzing decades of data, extracting fresh insights from the long transmitted signals from these intrepid explorers. Advances in data processing and simulation have allowed scientists to re-examine the Voyager's discoveries with a fresh perspective, revealing subtle interactions and phenomena that were previously overlooked. In this sense, the missions continue to pay dividends by fueling new theories and guiding the design
of future spacecraft. Looking to the future, Voyager's contributions extend beyond the realm of raw scientific data. The spacecraft have set a benchmark for the design and operation of deep space probes, inspiring an entirely new generation of exploration missions that aim to unravel the mysteries of the cosmos. With proposals for interstellar probes and advanced space observatories on the horizon, the spirit embodied by Voyager remains a guiding light in the ever-evolving narrative of space exploration. Moreover, Voyager's cultural impact endures. In an age where communication is instantaneous and space is more accessible than ever, the story of two humble spacecraft, launched over 4 decades ago, serves as a powerful reminder that human curiosity and ambition can transcend time and space. Whether it is through public exhibitions, virtual reality experiences, or renewed focus on deep space exploration by governmental and private entities alike, Voyager's legacy continues to permeate every facet of our approach to the cosmos. In the 2020s and beyond, Voyager's journey is a call to arms for every space enthusiast, scientist, and dreamer around the globe. It is a story that beckons us to keep questioning, to continue exploring, and to never lose sight of the wonders that lie just beyond our reach. As we reflect on the decades of discoveries, from the dynamic atmospheres of gas giants and the volcanic fury of distant moons, to the silent whispers of interstellar space, we are reminded that the quest for knowledge is timeless. The missions continue to teach us that every answer leads to new questions, and in that never-ending cycle of inquiry lies the essence of exploration. The extensive data and awe-inspiring images returned by the Voyager missions have fundamentally transformed our understanding of the outer planets. Before Voyager, our ideas of these remote worlds were largely shaped by theoretical models and limited observations from Earth-based telescopes. The detailed close-up images and in-situ measurements provided by the spacecraft dissolved long-standing mysteries, and often replaced them with new, even more enthralling puzzles. In the case of Jupiter, the discovery of active volcanism on Io revolutionized planetary science. No longer was volcanism seen as a quiescent process restricted to Earth. It was now a dynamic, relentless force capable of reshaping entire celestial bodies. Similarly, Saturn's intricate ring system, with its unexpected gaps and gravitational resonances, challenged the simplicity of earlier models and opened new avenues for the study of disk dynamics in astronomical systems. These revelations sparked a paradigm shift, inspiring subsequent missions, such as Galileo, Cassini, and Juno, to delve deeper into planetary physics. The legacy of Voyager's discoveries is self-perpetuating. Each groundbreaking finding has seeded new hypotheses, which have, in turn, fueled further exploration and discovery. Moreover, the interplay between observational data and computer simulations grew stronger as a consequence of Voyager's success. Scientists refined their algorithms and models to encompass unexpected phenomena such as magnetohydrodynamic turbulence, plasma interactions, and the complex gravitational interplay among planetary rings and moons. Today's understanding of planetary atmospheres and interiors owes much to that foundational work.
The impact of the Voyager missions transcends the realm of pure science. In classrooms around the world, the story of Voyager has become a touchstone for discussing topics ranging from orbital mechanics to the ethics of interstellar communication. The Golden Record, with its eclectic array of sounds and images, is often cited as an embodiment of human culture, a snapshot of life on Earth sent across the void. Documentaries, books, and countless media programs have woven the narrative of Voyager into the cultural fabric of our society. It is not uncommon for generations to revisit the iconic images of swirling storms, icy moons, and intricate ring systems, each reawakening a sense of wonder and igniting a passion for space exploration. In a world where technology evolves at breakneck speed, Voyager stands as a timeless reminder of human creativity, perseverance, and the relentless pursuit of knowledge. The legacy of Voyager also finds expression in popular art and literature. Science fiction writers and filmmakers have long drawn inspiration from the spacecraft's odyssey, using it as a metaphor for the human journey toward self-discovery. This cross-pollination between science and art enriches our cultural consciousness, reinforcing the notion that exploration is not just a scientific enterprise, it's a deeply human one. One of Voyager's most enduring contributions has been its pioneering role in interstellar exploration. As the spacecraft crossed the heliopause and ventured into the uncharted realms of interstellar space, they provided the first direct measurements of the complex environment beyond the protective bubble of the sun's influence. Such data have been instrumental in refining our understanding of the boundaries of our solar system and the properties of the interstellar medium. The interstellar medium is a sparse, tenuous environment populated by charged particles, cosmic rays, and magnetic fields. Prior to Voyager, our knowledge of this region was largely speculative. With its detailed observations, Voyager illuminated the subtle interplay between solar and interstellar forces, offering clues about the broader dynamics of our galaxy. These insights are helping researchers piece together puzzles regarding the evolution of cosmic structures, the formation of stars, and even the behavior of galactic magnetic fields. In essence, Voyager's bequest to interstellar science is twofold: a trove of empirical data that continues to spur scientific inquiry, and a legacy of pioneering spirit that encourages future missions to journey ever farther into the cosmos. By bridging the gap between the familiar territory of our solar system and the mysterious expanse of the galaxy, Voyager has forever expanded the boundaries of human understanding. The inaugural years following the launch of Voyager 1 and Voyager 2 were characterized by meticulous calibrations, early encounters with Jupiter's formidable magnetosphere, and the realization that even the most detailed pre-launch expectations were soon to be outpaced by actual discoveries. In these embryonic years, the spacecraft sent back not only data, but also images that captured the swirling, dynamic nature of Jupiter's atmosphere, images that would go on to define a generation's perception of our solar system. Early findings brought the unexpected discovery of moon surfaces that were far from static. Volcanic activity on Io, with plumes of sulfur evolving against a backdrop of stark red hues, upended previous notions of geological tranquility beyond Earth. Similarly, the ethereal wisps within Saturn's rings offered hints of a delicate balance between gravitational forces and particle collisions. Each piece of data was analyzed, reanalyzed, and found to be a stepping stone toward even greater insight. Scientific publications poured in with detailed analyses of atmospheric dynamics, gravitational interactions, and magnetic structures. International collaborations flourished as researchers from across the globe worked together, their collective curiosity knowing no bounds. This era was marked not by conclusive answers, but rather by an ever-growing list of questions that demanded innovative solutions and new theoretical approaches. The legacy of this period was clear. Voyager had not just expanded our observational horizons. It had sparked an intellectual revolution in the way planetary science was approached. Each transmission, each grain of data, became a piece in the intricate puzzle of our solar system. The 1980s ushered in an era of grand discoveries. As Voyager 2 swung by Uranus and Neptune, the scientific community was treated to a visual and data-rich extravaganza. Neptune's vibrant blue color, a result of the absorption of red light by atmospheric methane, captured the imagination of both scientists and the public. Its weather systems, characterized by super-fast winds and varying cloud patterns, led researchers to formulate new models of atmospheric dynamics far beyond the standard paradigms. One of the standout moments came with Triton, Neptune's largest moon. Its retrograde orbit and active geysers painted an image of an entirely distinct world, a frozen landscape, punctuated by the rare but dramatic eruption of volatile materials. Such findings challenged pre-existing notions of celestial mechanics and forced scientists to reconsider the evolutionary histories of planetary systems. Meanwhile, back at Saturn, the intricacies of ring dynamics were studied with newfound depth. Observations of the ring gaps caused by gravitational interactions with shepherd moons demonstrated that even seemingly stable structures were subject to continuous evolution and subtle nuances. The interplay between gravity, orbital mechanics, and particle dynamics became a recurring subject of both debate and admiration in the scientific literature of the time. Throughout the decade, public interest soared as images and data from Voyager fueled the imagination of millions worldwide. The Voyager spacecraft had become more than scientific instruments. They were ambassadors of human curiosity, carrying within them the seeds of countless future explorations. As the 1990s unfolded, the focus inevitably shifted from the planets themselves to the boundaries that defined our solar system. The transition zone, where the solar wind's relentless push gives way to the more sedate but equally intriguing conditions of interstellar space, became the next frontier. Voyager's instruments began to capture the properties of cosmic rays and interstellar particles with unprecedented clarity. One of the most profound moments of this period was the realization that the heliosphere, the vast bubble carved out by the sun's influence, had a distinct and measurable boundary. As Voyager 1 approached this threshold, its instruments registered a gradually changing environment as charged particles gave way to a medium that was both unfamiliar and rich with clues about the broader structure of our galaxy. This decade was defined by synthesis, a merging of decades-old data with innovative approaches to understanding the interstellar medium. Researchers employed advanced computer models to simulate the trajectories of particles deflected by the heliosphere, providing insights into phenomena such as cosmic ray modulation and magnetic reconnection. The work carried out during this time laid the foundation for a new interdisciplinary field that straddled astrophysics and heliophysics. Even as Voyager continued its journey, the ripple effects of these discoveries were felt in laboratories and lecture halls around the world. The notion that our sun, and by extension our entire solar system, was but a pale blue dot in the tapestry of the Milky Way, resonated with scientists and lay people alike. The 1990s were a decade of transformation, a period when the Voyager missions transcended their original mandate to become heralds of interstellar exploration. Entering the new millennium, the Voyager missions found themselves in a unique liminal space, neither confined to the neighborhood of familiar planets, nor fully immersed in the mysteries of interstellar space. The early 2000s were characterized by a blend of introspection and forward-looking optimism. Detailed reanalyses of Voyager data led to revisions in our understanding of magnetic field orientations, particle density variations, and the temperature gradients across the heliopause. as new instruments and methodologies just seemed on Earth. Older data from Voyager was reinterpreted in light of evolving scientific paradigms. Some of the most exciting results came from cross-comparing these datasets with those from concurrent missions and ground-based observatories. The synergy between historical data and modern techniques led to refined models of the physics governing boundary layers, magnetic turbulence, and the subtle transitions between solar and interstellar environments. The scientific community celebrated these revelations as further proof that the Voyager missions had, in many ways, only just begun to reveal their secrets. Each new analysis sparked conferences, publications, and fresh debates, proving that the legacy of these missions was intricately woven into the fabric of contemporary astrophysics. By the end of the 2000s, it had become indisputable that the Voyager missions were not relics of a bygone era. They were living documents of a journey that continually evolves with every passing second. Their data, preserved on analog and digital media alike, remains a cornerstone of space science, guiding both theoretical explorations and practical applications in deep space navigation and mission planning. The 2010s heralded a renaissance for the Voyager missions. With Voyager 1's historic crossing of the heliopause in 2012, the scientific narrative underwent yet another transformation. The spacecraft began probing regions where the familiar interplay of solar and planetary forces yielded to the unpredictable tapestry of interstellar space. In these uncharted depths, the data provided by Voyager took on new layers of significance, from deciphering the signatures of cosmic rays to mapping the subtle contours of magnetic fields. These years saw international collaborations intensify as researchers pooled resources to simulate the complex phenomena revealed by Voyager's instruments. The interplay between empirical observations and advanced computational models led to breakthroughs in our understanding of plasma physics and turbulent flows in space. In the realm of interstellar research, Voyager's data has become indispensable, inspiring new missions and renewing calls for a deeper exploration of our galactic environment. Public engagement also reached a crescendo during this time. Exhibitions, interactive media, and immersive documentaries allowed audiences to experience, albeit virtually, the wonder of the Voyager missions. For many, the Voyagers became symbols of an era when humanity dared to dream beyond its terrestrial fence, embodying the spirit of exploration in every byte of data and every snapshot of distant worlds. Today, even as the spacecraft edge ever closer to the limits of their operational capacities, their impact endures. Every transmission, every measured fluctuation in the interstellar environment continues to refine the narrative of cosmic evolution and the inexorable
quest to understand the universe. Although the Voyager missions were
conceived decades ago, their influence on the design, goals, and aspirations of modern space exploration is unmistakable. Engineers and scientists now draw upon the lessons learned from Voyager to design more resilient, data-rich missions that aim to peel back further layers of cosmic mystery. Future probes, whether they venture to explore the icy moons of the outer planets, study the intricate dance of material around distant stars, or ultimately set their course for interstellar travel, carry the indelible imprint of Voyager's pioneering spirit. Initiatives like the proposed interstellar probe, which aims to build on the groundwork laid by Voyager, demonstrate that the quest to explore is an ever-evolving journey. With advancements in propulsion, miniaturized instrumentation, and artificial intelligence-based navigation, The lessons gleaned from Voyager ensure that every new mission is equipped to handle both the familiar and the unknown. Furthermore, the integration of new observational techniques, such as high-definition imaging, spectral analysis, and real-time data processing, promises to augment the legacy of Voyager. In the coming years, interplanetary and interstellar missions will not only build on the scientific foundations established by Voyager, but will also seek to address unanswered questions about life, matter, and cosmic origins. Yet, the legacy of Voyager transcends the realm of technical achievements and scientific metrics. It is a story that stokes our collective imagination and inspires philosophical inquiry about our place in the universe. The Golden Record, with its carefully curated collection of Earth's sounds and images, is an enduring symbol of our desire to communicate, to be remembered, and ultimately, to understand that our small blue planet is part of a much larger story. For educators, artists, and thinkers alike, Voyager represents a reminder that the pursuit of knowledge is as important as it is unending. The narrative of these spacecraft stokes human curiosity, prompting us to ask not only what lies out there, but also, who are we in the vast cosmic context? This dual invitation, scientific exploration coupled with philosophical reflection, ensures that Voyager's journey remains timeless. As we continue to unravel the mysteries of the cosmos, the inspirational pull of Voyager provides the impetus for questioning, learning, and dreaming. In the laboratory, at the observatory, and in the hearts of millions around the world, the spirit of Voyager endures. With Voyager now a sentinel on the threshold of interstellar space, many scientists look forward to the next chapter in humanity's great expedition. The scientific data still flowing in, though gradually diminishing in volume, represent a living chronicle of our sun's interface with the galaxy. Future missions will not only continue this legacy,
but will build upon it. As we stand on the cusp of a new era of space exploration, one that contemplates
manned missions to Mars, robotic explorers beyond our solar system, and even thought experiments about interstellar travel, the Voyager missions remain a beacon that guides and motivates. They challenge us to reimagine the boundaries of human possibility and inspire technological innovations that will propel our species to yet undiscovered realms. The voyage of Voyager, from detailed planetary studies to the exploration of interstellar space, is a living testament to the human spirit, a symbol that even when our tools grow antiquated, our quest for knowledge never does. Looking ahead, the legacy of Voyager will continue to be interlaced with the innovative endeavors of upcoming missions, each one a chapter in the endless narrative of cosmic exploration. From its inception in a hopeful era of burgeoning scientific inquiry to its current position as an interstellar wanderer, the timeline of Voyager's discoveries is as much a scientific narrative as it is an emotional one. It speaks to the determination and curiosity that define the human race, a drive to never rest until we have explored every corner of our existence. Over the decades, every new image, every unexpected data point, has not only deepened our knowledge of the planets and the cosmic environment, but has also enriched our cultural and philosophical perspectives. Through the sweeping vistas of distant worlds and the quiet murmur of interstellar space, Voyager invites us to ponder the vastness of it all and our own fragile yet wondrous place within it. The legacy of Voyager is a tapestry woven of countless threads, scientific breakthroughs, technical marvels, cultural touchstones, and the enduring human spirit. It reinforces the idea that our quest for knowledge is a continuous, ever-evolving journey, one that transcends generations and beckons us onward, ever deeper into the unknown. Personal reflections. Lessons learned from Voyager. For many who have followed the Voyager missions, these spacecraft represent more than just scientific instruments. They embody a spirit of exploration that resonates on a personal level. The imagery of swirling storms on Jupiter, the serene majesty of Saturn's rings, and the icy mysteries of Neptune's moons evoke a sense of wonder and remind us of the boundless possibilities that lie beyond the familiar. Each discovery also serves as a metaphor for our own journey, that the pursuit of truth and knowledge is fraught with challenges, unexpected turns, and the ever-present thrill of venturing into uncharted territory. Whether you are a scientist examining raw data or an amateur astronomer gazing up at the night sky, the story of Voyager offers a deeply personal reminder that exploration is a fundamental part of what it means to be human. As we reflect on decades of observations and revelations, we are inspired to ask new questions, to dream of far-off worlds yet to be explored, and to recognize that the adventure of discovery continues in the future. Voyager has taught us that even in the vast darkness of space, there is light waiting to be discovered. In the annals of space exploration, very few missions have encapsulated the breadth and depth of discovery as thoroughly as the Voyager missions. Their narrative is interwoven with scientific breakthroughs, technological triumphs, and philosophical musings that continue to resonate with both experts and laypeople alike. As we delve deeply into every moment of these expeditions, we uncover layers of meaning that reflect humanity's eternal desire to explore the unknown. In this extended section, we explore the nuanced aspects of Voyager's trajectory, from the early technical challenges during launch and trajectory corrections to the mesmerizing interplay of gravitational forces that made the grand tour possible. We recount the meticulous planning that went into selecting the flyby sequences of Jupiter, Saturn, Uranus, and Neptune, a choreography dictated by celestial mechanics that continues to astonish even the most seasoned astrophysicists. Detailed accounts of instrument calibrations, power management strategies, and upgrades over the decades further illustrate the ingenuity behind these crafts. Each engineered solution addressed the unpredictable challenges of deep space travel, ranging from the harsh conditions of outer planetary environments to the extended periods of isolation that demanded exceptional reliability. The data analysis teams, spanning multiple generations of scientists, have continually revisited and reinterpreted the treasure trove of data beamed back by Voyager. Their work has yielded insights into plasma physics, atmospheric chemistry, and the very laws that govern celestial mechanics. Collaborative efforts across continents and disciplines underscore the universal relevance of these findings, reinforcing that the legacy of Voyager extends far beyond its technological achievements. Furthermore, the philosophical implications of Voyager's journey are profound. The Golden Record, as an artifact of human culture, encapsulates dreams, aspirations, art, and science in a single object hurtling through space. This symbolic representation has ignited debates on the ethics and responsibilities of space exploration, inviting thinkers from various fields to engage in dialogues about the future of humanity in a vast universe. As we immerse ourselves in this extended analysis, we reflect on how Voyager has redefined not just the parameters of scientific inquiry, but also our collective imagination. The tremendous challenges of deciphering faint signals from the edge of our solar system have led to innovations that ripple outward into numerous fields, ranging from telecommunications to robotics. In classrooms across the globe, educators use the story of Voyager to illustrate the intersection of art, science, and technology. Students learn not only about physics and astronomy, but also about the history of human aspirations, a history embodied by these two spacecraft. Through interactive exhibits and digital archives, The Voyager missions continue to inspire the next generation of scientists, engineers, and dreamers. Today, as missions become more ambitious and technology continues to advance at an unprecedented pace, the foundational work of Voyager remains a critical reference point. Its legacy serves as a reminder that the pursuit of knowledge is a collective, intergenerational effort, a continuous dialogue between what is known and what remains to be discovered. Moreover, the holistic impact of Voyager transcends traditional scientific boundaries. It has woven itself into the cultural psyche of society, becoming a symbol of hope, resilience, and human ingenuity. The questions it raised about our ability to reach out to unknown worlds and possibly communicate with extraterrestrial intelligences continue to challenge our perceptions of isolation and interconnectedness in the cosmos. As we compile this comprehensive narrative stretching across decades of diligent research and heart-stirring imagery, we are reminded that every step taken by Voyager is etched into the annals of our shared history. Its journey is not just a record of what has been accomplished, but an ongoing invitation to explore what lies ahead. In summarizing our reflections, we come to appreciate the dual legacy of the Voyager missions, a scientific odyssey replete with discovery and a cultural phenomenon that speaks to the very essence of what it means to be human. The data, replete with minute details and complex interactions, will continue to fuel research and inspire creative endeavors for decades to come. As we conclude this extended analysis, we invite you to reflect on the transformative power of exploration. The enduring legacy of Voyager is not merely found in cold data or faded images. It lies in the passion and wonder that these missions continue to ignite in all of us. The latest transmission from Voyager is nothing short of a technical anomaly, defying expectations and challenging established protocols for deep space radio communications. Advanced signal processing techniques have been applied to isolate and study the nuances embedded within this broadcast. Let's explore the different components of this technical revelation. The transmission is received on a frequency that has long been associated with standard deep space communications, typically in the ultra-high frequency, UHF, or X-band, ranges allocated for interstellar data. However, what sets this particular signal apart is its modulation pattern. Rather than the typical sinusoidal or binary coding used in standard communications with spacecraft, the signal exhibits irregular bursts interspersed with low-amplitude modulations. These features were first detected by monitoring stations at the Deep Space Network facilities, where unusual patterns in the signal's timing were observed. Detailed Fourier analysis of the waveform has revealed that the signal contains several distinct frequency clusters that are not normally exhibited by the operational parameters of the Voyager instruments. Researchers have noted these clusters vary in amplitude and timing, suggesting that they may represent either an unintentional byproduct of instrument degradation or, perhaps more intriguingly, a hidden coding scheme that has yet to be deciphered. Tests have ruled out many known errors associated with deep space digital communications, indicating that we may be witnessing something truly unprecedented. To further decode the mystery behind the transmission, a time series analysis was conducted to map out the temporal characteristics of the signal. Using advanced algorithms, scientists decomposed the signal into its constituent parts, isolating the rapid pulses from the underlying modulated wave. This analytical approach has uncovered a periodicity that hints at an intentional encoding pattern, almost as though the probe was transmitting a form of communication that resembled an ancient Morse code or even a digital fingerprint. What makes this analysis significant is the discovery of recurring signature motifs, patterns that repeat at regular intervals despite the chaotic appearance of the waveform. Some researchers have noted that these patterns could correspond to natural oscillations within the electronics of the probe. but others contend that the structure is too precise and intentional to be dismissed as mere chance or technical malfunction. The possibility that these patterns might be carrying data about the outer reaches of our solar system, or even interstellar phenomena, cannot be taken lightly. Understanding the environment in which Voyager operates is critical to interpreting its latest transmission. Since its launch, the probe has been exposed to extreme conditions, cosmic rays, solar wind fluctuations, and the intrinsic aging of its onboard systems. Engineers have repeatedly stressed test models of Voyager's hardware to predict potential degradations in signal quality. The latest analysis suggests that while aging components might introduce noise or distortion, the structured anomalies found in the transmission exceed what one would expect from natural wear and tear. Researchers have meticulously compared the signal against historical data from Voyager. In doing so, they have isolated components of the waveform that deviate from predicted models. These deviations have raised questions. Are they indicative of an unexpected interaction between the probe and a previously uncharted region of interstellar space? Or could the anomalies be a harbinger of new physics at play in the cosmic medium? The equipment's response to cosmic rays and natural interruptions in deep space communication is well documented. Yet this new signal seems to resist explanation by conventional models. This deviation forces us to reconsider our assumptions about electronics operating in interstellar conditions. Beyond the technical characteristics of frequency and modulation, one of the most tantalizing prospects is that the signal may contain encoded data. Some theoretical models propose that the observed patterns could be binary or even multi-level code, a form of digital language that, once deciphered, might reveal new insights into the space beyond our solar system. Preliminary tests using error correction algorithms and pattern recognition software have shown that attempts at decoding the signal yield repetitive sequences that mirror the structure of data packets. Although a definitive decoding remains elusive, a growing consensus among experts is that the signal might be intentionally engineered. Whether by an inadvertent mixing of onboard experimental data or a more profound discovery regarding the environment through which Voyager is currently traveling, we are on the cusp of unveiling a new chapter in interstellar exploration. The data-bearing potential of the transmission could, in the future, offer insights into the nature of cosmic radiation, the structure of space itself, or even interactions between unknown interstellar phenomena. As we piece together the technical puzzle, an important question emerges. What are the broader implications of Voyager's latest transmission for our understanding of the cosmos and the future of interstellar exploration? Voyager has long served as a window into the outer realms of our solar system. With every new transmission, scientists are afforded a rare opportunity to learn about the environments beyond the protective bubble of our heliosphere. The current signal, in its complexity, may be indicative of interactions with phenomena that are largely theoretical. Its specific frequency modulations and encoded patterns could be influenced by the interstellar medium, a magnetized plasma with properties that remain one of the great ambiguities of modern astrophysics. Some researchers propose that the various clusters in the frequency spectrum could be a direct consequence of the way the interstellar medium distorts electromagnetic waves. Others speculate that the unusual signature may reveal the presence of cosmic phenomena such as dark matter aggregations or regions of anomalous radiation. Thorough investigations in this realm might ultimately help us refine our models of cosmic structure and expand our understanding of the universe beyond our familiar stellar neighborhood. The enigma surrounding this transmission is also driving innovation in deep space communication techniques. Traditionally, communications with distant spacecraft have relied on established methods that prioritize reliability over complexity. However, Voyager's anomalous signal underscores the need for updated and more adaptive signal processing methods, Its subtle yet structured modulations have encouraged engineers to re-examine old assumptions, leading to innovations that might prove crucial for future missions venturing even further into deep space. This evolution in deep space communication promises not only enhanced data fidelity, but also the potential for the transmission of higher volumes of critical scientific information. In particular, the possibility of encoding richer data sets in an environment full of interference challenges the concept of how we design spacecraft communication systems. The lessons learned from deciphering this mysterious signal may directly inform the development of next-generation communication protocols, ensuring the future probes can transmit data back to Earth with even greater accuracy and detail. Another critical implication of this discovery is its impact on our understanding of aging spacecraft. Voyager's persistent signal, replete with unexpected anomalies, invites an in-depth analysis of how instruments respond to the extreme conditions of interstellar space over extended periods. As engineers study these effects, they are gaining valuable insights into how deep space missions might be designed to function for decades, or even centuries, in conditions far harsher than those encountered within the solar system. The reliability and longevity of deep space probes are of enormous importance for the future of interstellar exploration. If the anomalies observed in the transmission are linked to previously unrecognized environmental factors, future missions may need to incorporate new materials, redundant systems, or enhanced shielding to ensure consistent performance. The ongoing study of Voyager's components and its unexpected data streams is already influencing the engineering designs of upcoming missions that seek to traverse the boundary between our solar system and the interstellar medium. Beyond the technical and practical implications, Voyager's latest transmission beckons a broader philosophical reflection on our place in the universe. For decades, the Voyager mission has symbolized human ingenuity and our insatiable desire to explore the unknown. The possibility that this venerable probe has stumbled upon novel phenomena serves as a reminder that the universe remains full of surprises, many waiting to challenge our scientific paradigms. This discovery forces us to ask profound questions. What do these anomalies tell us about the nature of space, time, and even our trajectory as a civilization? Is it possible that the boundary between known and unknown is more fluid than previously thought? As we carefully analyze every aspect of this signal, we are not only expanding our technical capabilities, but also reshaping our collective vision of humanity's future among the stars. In the wake of these observations, the scientific community is rallying to launch a coordinated research initiative that will put every resource and expertise at its disposal. International agencies, university laboratories, and independent researchers are converging around the data to collaboratively investigate signals' origins and implications. One of the primary pathways forward is the improvement and cross-validation of observational techniques. The Deep Space Network, along with supplementary facilities around the globe, is set to increase the cadence of data collection, refining both spatial and spectral resolution. By cross-referencing the data against historical records of Voyager's transmissions, researchers hope to identify subtle shifts in the signal profile that could be traced back to environmental factors or internal probe dynamics. Advanced telescopes and new signal analysis methodologies are being integrated to monitor not only Voyager, but also the dynamic environment in which it operates. With the advent of machine learning algorithms and pattern recognition technologies, scientists are better equipped than ever to detect subtle anomalies that might otherwise go unnoticed. These technological enhancements promise to shed light on differences between expected signal degradation and the unusual patterns observed in this latest burst of data. The mystery of the transmission has inspired an unprecedented level of collaboration among international research institutions. Data sharing agreements have been established, and teams from disparate disciplines, including astrophysics, electrical engineering, computer science, and even theoretical physics, are working together to decode the underlying message. This synergy is not only enhancing our understanding of the current situation, but is also establishing a paradigm for future cooperative space exploration efforts. Collaborative initiatives such as these are proving invaluable. By pooling resources and expertise, the scientific community is able to tackle the challenge from multiple angles, refining signal algorithms, performing simulated reconstructions of deep space conditions, and even exploring novel hypotheses that challenge conventional wisdom. The international nature of this research effort underscores the idea that space exploration is a unifying endeavor, one that transcends borders and brings humanity together in the pursuit of cosmic knowledge. The anomalies in Voyager's transmission force us to revisit and refine our theoretical models governing interstellar propagation. Traditional models of electromagnetic wave dispersion, signal degradation, and noise interference are being re-examined in light of this new data. A number of hypotheses have been proposed, including the possibility that the interstellar medium contains microstructures or plasma instabilities that were previously underappreciated, and that these structures may be modulating the signal in a coherent manner. Some scientists have also speculated that this transmission might be capturing interactions between Voyager's electronics and unidentified cosmic phenomena. This hypothesis, although still in its infancy, holds the potential to stimulate breakthroughs in astrophysics, challenging us to expand the boundaries of what we consider possible. Theorists are busy adapting current models to incorporate these unexpected interactions, paving the way for more robust frameworks in the near future. Perhaps the most exciting outcome of this discovery is its impact on the design and execution of future interstellar missions. Lessons learned from Voyager's ongoing journey and its latest transmission will directly inform the engineering decisions behind the next generation of space probes. From improved deep space communication protocols to resilient onboard processing units capable of withstanding cosmic radiation for extended periods, every insight will help shape how humanity approaches the final frontier. These advancements are not just technical, they are part of a broader quest to better prepare for long-duration missions that may eventually venture into realms even further from our solar system. Moreover, the collective experience of deciphering and understanding this mysterious transmission will likely spark innovative approaches to problem-solving in extreme environments, a vital asset as we begin to contemplate missions to nearby star systems and beyond. Despite the depth of current investigations, the true nature of Voyager's latest transmission remains shrouded in mystery. Every new piece of data raises further questions, and the scientific community acknowledges that we have only begun scratching the surface of this puzzle. One of the most tantalizing possibilities is that the signal contains a hidden code, a cryptic message embedded within the seemingly random modulations. Some researchers argue that the periodic motifs, once isolated from background noise, might represent a rudimentary form of data encoding. This could be compared to an interstellar version of a coded message, or even an ancient language waiting to be deciphered. Decoding such a message would require not only advanced algorithms but also an interdisciplinary approach that draws from digital communications, cryptography, and linguistics. The idea is both enticing and humbling. What if Voyager, in its silent voyage, has stumbled upon a means to communicate that transcends time and space? While it is premature to jump to extraordinary conclusions, the possibility remains a significant motivator for ongoing research. An alternative hypothesis is that the peculiarities are not evidence of an intentional code, but rather the result of complex interactions between the probe's signal and the interstellar medium. As Voyager traverses regions of varying density and magnetic field strength, it is plausible that the signal becomes modulated in unforeseen ways. These modulations, when analyzed closely, might reveal key properties about our galaxy's interstellar environment that have so far eluded detection. For instance, the presence of plasma instabilities or filament structures in the medium could alter the propagation characteristics of the signal, leaving distinctive imprints in the frequency clusters that our instruments can detect. Recognizing these signatures might help us refine our understanding of interstellar space and even guide the development of improved models for wave propagation across cosmic distances. A more conservative perspective considers the possibility that the anomalies are a manifestation of instrument artifacts or unforeseen calibration issues due to the harsh realities of interstellar travel. Although extensive cross-checks and redundancies have been built into the Voyager systems, the passage of time and exposure to various space hazards might lead to non-standard behavior from the aging electronics. Yet, the precision and recurring nature of the signal's patterns suggest that while instrumentation errors may contribute, they alone are unlikely to explain such a structured modulation. Even if some aspects of the signal are found to be inadvertent artifacts, the observed deviations still open up avenues for deeper inquiry into how instruments behave in extreme environments. This challenge is prompting scientists to innovate new calibration techniques and error correction methods that will be indispensable for the next generation of deep space probes. Beyond the technical debates and varied hypotheses lies a broader quest, the challenge of interpreting data that defies conventional wisdom. Voyager's unexpected transmission invites us to revisit the boundaries of our scientific paradigms and adopt a mindset that is receptive to new ideas. It stands as a reminder that space is a realm of infinite possibility, where each mysterious signal is both a puzzle and an opportunity for discovery. As we continue to probe the unknown, every anomaly, every unexpected twist, reaffirms our commitment to openness in the face of the extraordinary. Whether the distortion in the signal is a result of complex cosmic interference, a fragment of encoded information, or a combination of multiple factors, its significance is clear. It compels us to ask questions, refine our tools, and expand the horizons of human knowledge. As we draw this exploration to a close, the shocking secret behind Voyager's latest transmission remains a subject of intense investigation and speculation. What began as a routine deep space signal has now become a beacon of curiosity, a call to every stargazer, scientist, and explorer to look beyond the obvious and delve into mysteries that challenge our perceptions of interstellar space. The technical analysis has shown us that within the seemingly erratic modulations of the waveform lies a structured message, one that may encode information about the interstellar medium, new physics, or perhaps even insights into the very nature of Voyager itself. Voyager's legendary journey continues to push the frontiers of human exploration, reminding us that in the depths of space, there will always be surprises waiting to be uncovered. The implications of this discovery are vast. The reimagining of deep space communication methods to a deeper understanding of how cosmic phenomena shape our universe. Each unanswered question and every novel hypothesis contribute to a dynamic field of research that promises to redefine our approach to exploring the cosmos. In our quest to obtain definitive answers, collaboration among international agencies, engineers, and theoretical physicists will be key. The spirit of exploration embodied by Voyager inspires us to push ever forward, to innovate, and to embrace the complexities of interstellar space with intellectual rigor and genuine wonder. We stand on the precipice of a new era, a time when the secret held within Voyager's latest transmission might be transformed from an enigma into a beacon of discovery. As the data continues to be analyzed and new theories emerge, one thing remains certain. The cosmic dialogue between humankind and the universe is far from over. Thank you for joining us on this immersive journey into the mysteries of deep space. If you found this documentary fascinating and you're eager to learn more about our cosmic neighborhood, please subscribe to our channel, like this video, and share it with your fellow space enthusiasts. For further detailed information and the latest updates on Voyager's mission, we encourage you to visit NASA's official website. As we close the chapter on today's exploration, let us leave you with a thought. Every transmission from the cosmic frontier is a reminder of our ceaseless curiosity and our eternal desire to understand the universe we call home. In this vast expanse, Voyager has become more than just a spacecraft. It is a symbol of human perseverance, hope, and the endless pursuit of knowledge. The future of interstellar exploration hinges on our ability to remain inquisitive and steadfast in the face of mystery. Whether it is a distinctive signal beamed from the edge of our known universe or an entirely new phenomenon waiting to be discovered, the quest for understanding will continue to guide us. The shocking secret behind Voyager's latest transmission stands as a testament to the unpredictable and wondrous nature of space, a domain where science meets the sublime. We invite you to carry forward the spirit of inquiry in every aspect of your own exploration of science. Continue to ask questions, seek out new answers, and never be satisfied with the limits of current understanding. The cosmic dialogue is ongoing, and your curiosity plays an essential role in this collective adventure. Once again, thank you for watching. Remember to subscribe, like, and share this video so that together we can spread the wonder of discovery far and wide. For more in-depth analyses and official updates on Voyager's journey, please visit NASA's website. Until next time, keep looking up, to the stars, to the unknown, and let the mysteries of the universe ignite your imagination. For those interested in a deeper technical dive, this section provides supplementary details on the data analysis methods and signal processing algorithms used to examine Voyager's latest transmission. Advanced Fourier and wavelet transforms were used to identify distinct frequency clusters. These clusters, observed in the 8 to 12 GHz band, display periodic modulation patterns which deviate from standard deep space telemetry. By applying autocorrelation functions and spectral density mapping, researchers isolated recurring pulse motifs in the time series. These motifs revealed a consistent periodicity, suggesting a non-random, encoded structure. Neural network algorithms trained on historical Voyager data were employed to detect anomalies in the signal. The output corroborated the presence of intentional modulation not attributed solely to cosmic interference. Comparative analysis between Voyager's current output and archival telemetry data allowed engineers to discount typical instrument degradation. The anomalies exceed expected deviations from long-term aging and cosmic radiation impacts. Recent computational simulations of electromagnetic wave propagation in turbulent plasma environments have offered potential explanations for the observed dispersions, highlighting regions where theoretical predictions match the transmission's characteristics. These technical notes serve as a resource for researchers and enthusiasts alike, offering a glimpse into the rigorous analytical processes behind contemporary deep space communications research. As advancements in technology continue to refine our observational capabilities, we are hopeful that ongoing studies will further elucidate the complexities of this signal, gradually transforming uncertainty into definitive scientific breakthroughs. In closing, we pay tribute to the Voyager mission, a symbol of ambition, tenacity, and the unquenchable thirst for exploring the unknown. Voyager's legacy is not only treasured for the discoveries it has enabled, but also for the inspirational spark it has ignited in generations of scientists and dreamers. The latest transmission, with its blend of mystery and scientific potential, encapsulates the essence of human endeavor in space. It stands as a powerful reminder that even after decades of exploration, the universe continues to surprise us, inviting us to peel back layers of cosmic obscurity and uncover its deepest secrets. As we continue to monitor this signal, let its story inspire all who hear it to embrace curiosity, pursue knowledge relentlessly, and celebrate the awe-inspiring tapestry that is our universe. Thank you for being part of this journey into the heart of interstellar mystery. Together, we can unlock the secrets written in the stars and chart a future where the unknown inspires us to dare, explore, and dream. The Voyager missions have redefined our understanding of the universe, forever altering the way we see our solar system and our place within the cosmos. From the initial spark of a vision in the 1970s, through decades of pioneering discoveries, to the present day where these ancient travelers now drift in interstellar space, the story is one of relentless curiosity, unparalleled ingenuity, and an unwavering desire to know the unknown. As you have journeyed through this documentary narrative, we trust that the wonders of the Voyager missions have kindled in you a passion for exploration and a curiosity that extends beyond the stars. Each chapter in this story is a reminder that every discovery, however minute, contributes to the grand mosaic of scientific understanding, a mosaic that continues to evolve with each new observation and every fresh insight. The legacy of Voyager is not confined to dusty archives or static images on a screen. It lives on in laboratories, classrooms, policy discussions, and in the dreams of anyone who has ever looked up at the night sky in wonder. As the spacecraft travel farther into the depths of interstellar space, they challenge us to keep dreaming, to keep seeking, and to perpetually ask the questions that define our existence. If you enjoyed this in-depth exploration of Voyager's latest data, please do not forget to subscribe to our channel, click the like button, and share this documentary with others who are passionate about space science and exploration. For more detailed information and updates, please visit NASA's official website. Until next time, keep your eyes on the heavens and your mind open to the marvels of the cosmos.